66 million years ago, the Cretaceous world was bathed in a perfect golden afternoon as warm breezes carried the scent of ancient forests, towering ferns, and lush green vegetation that flourished across a vast, fertile planet. Everything seemed eternal, vibrant, and full of life. Then, without warning, that perfect day became the last day for the dinosaurs. What was Earth truly like in those final, peaceful hours before it all vanished? The Cretaceous period began 145 million years ago and ended 66 million years ago. It was the last period of the Mesozoic era, the age of dinosaurs. It followed the Jurassic period and immediately preceded the Paleogene period, the first period of the Cenozoic era, the era we live in today. Durationing to nearly 80 million years, the Cretaceous period was the longest geological period in the Phanerozoic era, a geological era that began approximately 539 million years ago. This period is divided into two main phases, the early Cretaceous from 145 to 100 million years ago, and the late Cretaceous from 100 to 66 million years ago. It was during this late Cretaceous period that the world of dinosaurs reached the peak of its diversity and glory, before everything ended on a single fateful day. Not only was the span of time immense, but the appearance of our planet back then was vastly different from what you see on today's maps. The continents of Earth were once joined together into a single supercontinent known as Pangaea. It formed around 335 million years ago, but by the end of the Jurassic period, this massive landmass began to break apart. This process continued throughout the Cretaceous period, and by the end of that period, the continents had moved close to their present-day positions. At that time, Earth was significantly warmer than it is today, with little to no ice at either the Arctic or Antarctic. Sea levels fluctuated, but were generally much higher. In fact, at certain points, sea levels rose up to about 558 feet higher than today. Shallow seas formed splitting parts of the continents. For example, toward the end of the Cretaceous, the western interior seaway divided North America into two separate landmasses. At its greatest extent, this seaway stretched over 1,864 miles long, was nearly 621 miles wide, and reached depths of about 2,493 feet. In In such a warm and watery world, gigantic creatures emerged. But have you ever wondered how nature could have nurtured these eating machines, weighing tens of tons? Long-legged dinosaurs may have lived and moved in large herds, but how could the Cretaceous environment support so many giant herbivores? We have a very mammal-centric view of the world, but long-legged dinosaurs were very different from mammals. I suspect they had very different metabolisms and probably didn't need to eat as much food. They may also have survived on lower-quality plant matter, Susie said. They hatched from eggs slightly smaller than a soccer ball, yet could grow into animals weighing up to about 66 tons. We can see that they accumulated bone tissue very rapidly, meaning they grew at an extraordinary pace and likely had to consume vast amounts of food to fuel that growth. Scientists believe their metabolism changed as they matured. Early in life, they had a very fast metabolic rate, but as they grew larger, their growth slowed and their metabolism became significantly slower. Alamosaurus was a member of the Titanosauria that lived in North America during the late Cretaceous period. It was among the last groups of non-avian dinosaurs to exist aside from birds. These enormous long-necked dinosaurs may have stripped cellulose-rich leaves from conifer trees, a type of vegetation that would have taken a long time to digest in their massive digestive systems. They may also have eaten the cones of these trees. Cones contain seeds. They differ from leaves because they contain starch, not just cellulose, so you get far more nutrients from eating them, said Paul Barrett. Herbivorous dinosaurs may also have been eco-engineers, meaning they altered their habitats through their behavior. When these dinosaurs ate plant seeds, they may have digested the seeds and excreted them through feces, helping to disperse the seeds throughout their habitat as they moved. But did Cretaceous plants have a way of avoiding becoming dinosaur food? Paul points out a few plant groups that may have done just that. Of the approximately 370 species of plants in the Cicadaceae family that exist today, most are toxic to most mammals, with only a few primates able to digest them. If Cicadaceae plants were so poisonous during the Jurassic and Cretaceous periods, perhaps that would have been enough to stop dinosaurs from eating them. Bennetai tails is an extinct group of plants that closely resembled cycads. Cycads have cones at the top of the plant, while in many Bennetai tail species, the cone-like structures are located deep within the stem, Paul explains. It's possible these plants were protecting their reproductive organs by encasing them in a kind of armor-like covering, rather than leaving them exposed and vulnerable to dinosaurs. Some plants may have survived thanks to their high adaptability. For example, the Araucaria araucana plant appears almost completely covered in armor with thick scale-like leaves and sharp edges. This group of plants reached its peak of diversity during the Jurassic and Cretaceous periods. That perfect balance between animals and plants seemed destined to last forever. But fate called upon the blue planet with an uninvited guest from space. An ordinary day suddenly becomes the last day. The Cretaceous-Paleogene extinction event, formerly known as the Cretaceous-Tertiary extinction, was one of the most devastating biological crises in Earth's history. This event led to the extinction of all non-avian dinosaurs and most four-legged animals weighing more than about 55 pounds, with a few exceptions among cold-blooded survivors such as sea turtles and crocodilians. It marked the end of the Cretaceous period, and with it the close of the Mesozoic era, ushering in the beginning of the modern geological era, the Cenozoic era. In the geological record, this moment is preserved as a thin layer of sediment known as the KPG boundary, found worldwide in both marine and terrestrial rock formations. This boundary layer contains an unusually high concentration of iridium, a metal far more common in asteroids than in Earth's crust, pointing to a catastrophic extraterrestrial impact. Why could a single collision wipe out almost everything? Let's delve into the most horrific details of the catastrophe that reshaped life itself. In addition, many researchers have found more information about the Cretaceous-Paleogene extinction event, a major mass extinction event that occurred approximately 66 million years ago. This event is widely believed to have been triggered by a catastrophic impact from a massive asteroid or comet estimated to be about 9 miles in diameter. It struck Earth in what is now the Yucatan Peninsula. The collision released an unimaginable amount of energy equivalent to roughly 100 million megatons of TNT, unleashing global devastation. Towering tsunamis surged across oceans, firestorms ignited across continents, and the planet was thrust into extreme and rapid climate change. The environmental upheaval caused by the impact led to the extinction of approximately 75% of all species on Earth, notably including all non-avian dinosaurs, which had dominated terrestrial ecosystems for about 160 million years. These extinctions were further exacerbated by continued volcanic activity, releasing ash and toxic gases into the atmosphere, contributing to a dramatic reduction in sunlight and disrupting the food chain. This extinction event not only reshaped the planet, but also paved the way for the resurgence of mammals and other organisms, leading to a gradual recovery of biodiversity over millions of years. The discovery of the Chicxulub crater and related geological evidence in the late 20th century provided crucial evidence supporting the impact hypothesis, reshaping our understanding of this pivotal moment in Earth's history. Before nuclear winter arrived, the world experienced a devastating temperature purge. As debris flung into space fell back into the atmosphere, it was like billions of fireballs re-entering the atmosphere. Air friction created a phenomenon called an infrared radiation pulse. In less than 2 hours, the sky became a giant oven. Temperatures at ground level soared by hundreds of degrees Fahrenheit, much like inside a running pizza oven. This is the most sophisticated explanation for why giants like Alamosaurus became extinct so quickly. They were simply too large to find shelter. Conversely, life survives thanks to its natural insulation capabilities. Burrowing animals like our ancestors only needed to lie a few dozen centimeters deep in the ground to survive this thermal pulse. Aquatic species were also protected by the enormous specific heat capacity of water. Extinction was no longer a battle of the strong, but a battle of those who knew how to hide. When sunlight faded and photosynthesis ceased, the structure of life was turned upside down. Fresh ecosystems relying on green plants collapsed instantly. But in the darkness, another food web emerged, the detritus-based food web. This was the age of scavengers and microorganisms. When plants and dinosaurs died en masse, they created a massive amount of decaying biomass. Earth became a haven for organisms capable of digesting death. Fungi, insects, and small mammals that feed on roots or carrion became the only entities left with the energy cache to operate. We call these evolved zombie species that survived on the legacy of a dead world. Their omnivorous nature and adaptation to this waste energy source were the golden key that allowed our ancestors to navigate the darkness into the Paleogene era. This extinction, therefore, was not the end, but a great restructuring of the planet's energy flow. From the ashes of the Cretaceous period, our world was reborn. If that asteroid had deviated even a few degrees, perhaps human history would have had no mention of humankind. Don't forget to like and subscribe to join me in exploring more mysteries of ancient Earth.